Part 4, the difference quotient. Given a function f, the difference quotient of f is the expression f of x plus h minus f of x all over h. So what this represents, I'm going to show you with the graph what the difference quotient is. It's actually the slope of this line that I'm drawing right here. We call that a secant line. A secant line is a line that goes through 2 points on the graph. So that's these 2 black points there that we're going through. So we want to find the slope of that secant line. So this right here on the x-axis, this is our point x. And then this is x plus h, where h is just some number. So we add a little bit to x. Notice that then we have the first point here. This is the point x comma f of x. And this is the point x plus h comma f of x plus h. So if I want to find the slope of that line, so slope is change in y over change in x. So our change in y here would be f of x plus h minus f of x. And our change in x, this bottom part of our triangle, is x plus h minus x, which is just h. So my change in y over change in x, or rise over run, however you want to think about the slope, the change in y is f of x plus h minus f of x, and the change in x is h. So what we're doing is we're finding the slope of a secant line. For f of x equals x squared minus 2x plus h, find and simplify the difference quotient. I'm going to rewrite the expression for the difference quotient here, f of x plus h minus f of x all over h. So for this case, f of x plus h, that means substitute x plus h for all the x's in my function. So I have x plus h squared minus 2 times x plus h plus 1. So that's f of x plus h. Then we need to subtract f of x, so minus x squared minus 2x plus 1. And all of that is divided by h. So what I'm going to do now is simplify everything. And at the end, I want this h that is currently in the denominator to be gone. I'm going to somehow cancel it out. So my numerator now, if I do x plus h times x plus h, and then I have minus 2x minus 2h plus 1, distributing through the negative through the second parentheses, I get negative x squared plus 2x minus 1. And that is all over h. And then if I FOIL and combine like terms with x plus h times x plus h, I get x squared plus 2xh plus h squared. And I have minus 2x minus 2h plus 1 minus x squared plus 2x minus 1 all over h. Now the nice thing is that some things are going to cancel here. Notice I have an x squared minus x squared, which gives me 0. I have a minus 2x plus 2x, which is 0. And I have a 1 minus 1, which is 0. Now what I'm left with is 2xh plus h squared minus 2h all over h. Remember I told you I want to be able to cancel out that h in the denominator. So I'm going to factor out an h from the numerator. And I have 2x plus h minus 2 over h. And then these h's can cancel. And I am left with 2x plus h minus 2. And that is our difference quotient for the function f of x. For g of x equals 3 divided by 2x plus 1, find and simplify the difference quotient. Again, the difference quotient is f of x plus h minus f of x all over h. So in this case, f of x plus h would be 3 over 2 times x plus h plus 1. And then minus f of x, so minus 3 over 2x plus 1. And all of that divided by h. So what I'm going to do now is find a common denominator for those 2 fractions on top and combine those into one fraction. So first I'm going to write that as 3 over 2x plus 2h plus 1 minus 3 over 2x plus 1 all over h. So my common denominator is what I get when I multiply those 2 denominators. So my common denominator is 2x plus 2h plus 1 times 2x plus 1. And I'm not going to distribute through there because that I want to be able to cancel things out and it will make it harder to distribute at this point, so I will later. So I'm going to multiply this fraction by 2x plus 2h plus 1 over 2x plus 2h plus 1. So I'm multiplying by 1 because anything divided by itself is 1. And this fraction I'm going to multiply by 2x plus 1 over 2x plus 1. So now in my numerator, I have 3 times 2x plus 1 minus 3 times 2x plus 2h plus 1 over my common denominator, 2x plus 1 times 2x plus 2h plus 1. And that whole thing is divided by h, but dividing by h is the same as multiplying by 1 over h. So now I'll distribute through the numerator. Again, I'm not going to bother to distribute through the denominator, but in the numerator I have 3 times 2x, which is 6x. So 6x plus 3 minus 6x minus 6h minus 3 all over h times 2x plus 1 times 2x plus 2h plus 1. And again, some things in my numerator will cancel. I have 6x minus 6x and 3 minus 3. So I'm left with negative 6h over h times 2x plus 1 times 2x plus 2h plus 1. And then these h's cancel, and I'm left with negative 6 over 2x plus 1 times 2x plus 2h plus 1. And I am done. This is my difference quotient for g of x. Let's do one more example, this one with a square root. We want to find the difference quotient again, so we want to find f of x plus h minus f of x all over h. That would be the square root of x plus h minus 3 minus the square root of x minus 3 all over h. And again, my goal will be to be able to cancel out this h that's in the denominator. Actually, when you get to calculus, the next step when calculus students do this would be to make h equal to 0. So you need to have something where you're not going to divide by 0 if h equals 0. So that helps you remember what you're trying to do. So let's simplify that. And I'm going to do that by rationalizing the numerator. So to rationalize the numerator, I have square root of x plus h minus 3 plus square root of x minus 3. So we're multiplying the top and bottom by the conjugate of the numerator. The conjugate then has a plus in the middle instead of a minus. So when I do that, in the numerator, I have a difference of squares. So I have square root of x plus h minus 3 all squared. Then my outside and my inside terms cancel each other out because it's a difference of squares. And then I have the square root of x minus 3 squared. And that is all over h times square root of x plus h minus 3 plus square root of x minus 3. So in my numerator, the square root of something squared, the square root and the squared cancel out, and I have x plus h minus 3 minus x minus 3 all over h times square root of x plus h minus 3 plus square root of x minus 3. Simplifying in the numerator, I have x plus h minus 3 minus x plus 3, and still over my same denominator. Now in my numerator, I have an x minus x and a negative 3 plus 3. So I'm left with h over h times square root of x plus h minus 3 plus square root of x minus 3. Now these h's cancel, and I'm left with 1 over square root of x plus h minus 3 plus square root of x minus 3. And notice now, if I was a calculus student and I substitute 0 in for h, I would not be dividing by 0. So I am done. This is my difference quotient for h of x.